For lesson 4.2, we're going to identify congruent figures. So, congruent figures are figures that have exactly the same shape and the same size. So there's some examples there of congruent, same shape and size, and ones that are not congruent. When we have congruent figures, all of the parts of one figure are congruent to those corresponding parts of the other. So in congruent polygons, this means that the corresponding sides and the corresponding angles are congruent. A congruent statement is just listing the corresponding vertices in the same order. So for this figure that I have drawn here, triangle ABC would be congruent to triangle FED. So you write a congruent statement, which is writing out the actual triangle ABC with its corresponding sides in the same order. And then if I want to write each of the congruent parts, the corresponding angles, A would be with F, B with E, C with D. Then likewise the corresponding sides with AB would be AB with FE. BC with ED, and AC with FD. So in a triangle, you have 6 corresponding congruent parts. So our first example, we're going to write an actual congruent statement, just making sure that we write them in the correct order, or corresponding order, and then identify all pairs of congruent corresponding parts. And so in some cases, it might be easier to just write that part first, the corresponding parts. So angle K, I'll start with the angles. Angle S, we have one congruency marking, and the two congruency marking would be L with R and J congruent to T. Corresponding signs, JK, ST, KL, SR, and I'm just going in the order of the amount of congruency markings. And JL congruent to RT. So the congruent statement would be triangle JKL congruent to TSR. Is there any other way you could have written the congruent statement? Yes, you could have written it triangle KLJ congruent triangle SRT, or you could have wrote triangle AJK congruent to RTS. So we're going to use these properties knowing that I have congruent figures and find missing values. So I have DEFG congruent to SPQR. So if it wants me to find the value of x, which is just by itself with that side, QR, its corresponding part would be FG. So QR is 2x minus 4, and FG is 12. So they must be equal since they're congruent. So x equals 8. To find y, take notice that the y is a part of Q, and Q corresponds with F. So, and I already have the value of x. Oops. So 6y plus x, which is 8, must equal f, which is 68. To answer these follow-up questions, what are the measures of S and R? Well, S corresponds to D, so it should be the same as D, which it says 102. And R corresponds to G. If you divide the wall into orange and blue sections along JK, will the sections of the wall be the same size and shape? Explained. So first off, we want to list the corresponding parts. So I can see that AJ is congruent to KC, and DK is congruent to JB. AD is congruent to BC, and JK is going to be congruent to itself. So I have all the sides of angle A congruent to angle C, angle D congruent to angle B. 1 would be congruent to 4 alternate interior angles, and 2 would be congruent to 3 alternate interior angles. So ADKJ will be congruent to CBJK. All the corresponding parts are congruent. Okay, pause the video and try the guided practice. Okay, at this last one, you have vertical angles. Your parallel lines. So P and then your sides. Okay, the third angles theorem just says that if you have two angles of one triangle congruent to two angles of another, then the third angles are also congruent. So looking at using that in a diagram, we have, if you split this into two triangles, the green one and the blue one, we have angle A congruent to B, which equals 45. And you have angle C congruent to D, which equals 30. Or we should say BCD. Let's just rewrite these. I should call that BCD congruent to ADC. So BDC and ACD is going to equal 180 minus the sum of the other two. Okay, doing a little proof. We have AD congruent to CB, DC congruent to BA, that's given. You can see that in our first line up there. AC congruent to itself, that's reflexive property. ACD, CAD, those are in the given line. Angle B congruent to angle D is your third angles theorem. So, two triangles are congruent, because that's the definition, congruent figures, that the corresponding parts are congruent. So how many pairs of sides and pairs of angles must you show are congruent when you use definition congruent triangles? That's the operative word, triangles. So you would use three pairs, and I mentioned this before, three pairs, congruent angles, and three pairs, congruent sides. Okay, pause the video and do the two guided practice questions. Properties of congruence are true for segments and angles, are also true for triangles. So you can do your reflexive property, symmetric property, and transitive property of congruent triangles. And we'll close out the lesson. What are congruent figures? Figures that have exactly the same shape and size. Okay, so you have the 4-2 assignment. Daily homework quiz, and the new assessments. So you can start doing the assignment the next day in class, and then the daily homework quiz and the assessment we do that evening. The assessment opens at 3 p.m. I forgot to mention that in the last video. Okay, this completes 4-2.